Hello everybody, welcome to my channel again. Today we're going to learn about gradient boosting algorithm for machine learning, right? In that, in order to understand what gradient boosting is, so let's just first check out the method on which it is based. It's the gradient descent method. You might have learned that in your stat class or in your school. um, it's a very important method, and here we're gonna learn about what's a gradient descent method, what's the algorithm flow, the types of gradient descent method, and after that we'll delve much more deeper into machine learning implementations of this method. That is, of course, in the second part of the this tutorial. All right, so what's the gradient descent method? So gradient descent method is basically the generic optimization algorithm that's capable of finding optimal solution to wide range of problems. Okay, it can be used on wide range of models or other kind of problems which you're using. Basically, the general idea here is to tweak the parameters iteratively in order to minimize the cost function. All right. So cost function, as you might see, it's basically it's just the measure of error between our predicted values and the original data. Okay. So so let's just take an example. Here in linear regression, in order to find the linear relationships between continuous or categorical data, okay, you have an equation like y dash is equal to theta 0 plus theta 1 x1 plus that goes on up till theta n xn. So here the y dash is the predicted value, and the thetas, they are the parameters, and the number of x's there are the number of features. Okay, so what basically that's what is the goal is to estimate the parameter theta, so we can make general equation and we can use a predictive to predict the future values. So it's basically gives you the measure of error between the predicted and the original data. So basically our goal here is to reduce the cost function in order to improve our equation accuracy. Okay, so after that, after you have made the model, you want to make the model as general as possible. So in order to predict any future values, if you put the other values into it, then you get the right answers. Okay, so it's basically making a good, nice, decent equation there. Okay, okay, now let's continue with our next step. It's the gradient descent algorithm flow. So this algorithm attempts to find, the global minima of the cost function. So as you know that our goal here is to minimize the cost function, okay, in order to make the equation more general, all right, and in order to improve the accuracy of our model here. Okay, so for that, we first initialize weights with the random values and calculate the error. That's the SSE or the cost function. SSE is just the case I've taken here. This is in case of linear regression. It could be anything. It depends on your model. All right. So the next thing is you calculate the gradient. Okay. So what's the gradient is? Gradient is, as I told you earlier, it's a change in the SSE or the cost function when the weights are changed by a very small value from the random value. Okay, as the first step shows here, that the algorithm attempts to find the global minima and then it initializes weights with random values. So after it has initialized with random values, you need to change it off, right? And by changing it off, you need to know which direction you are going. So the gradient basically tells you which direction to go. Okay, and by taking them and by taking which values and on which direction your error would be minimized, that's what gradient tells you. All right, and then what you do is you use the new weights for prediction and calculate the new SSE. Okay, so adjusting and increasing the value according to the direction where the cost function would be more minimized. And you repeat the above steps until the weight significantly reduces, okay, or your gradient is zero. Okay, this the small value which I mentioned, that which you need to multiply it to the gradient. Okay, that is called the learning rate. Yeah, it's actually the hyperparameter that the algorithm uses to converge either by taking bigger steps or smaller steps. It depends on which on the algorithm or on your data. Okay, so we'll know more about it when we see pictorial. Okay, so let's see a pictorial representation of it. Okay, so this is how. So consider this is your graph here, and consider you've taken an initial weight here. Okay, as we as I showed you in the earlier slide. Okay, you take a initialized weight with random values, and you calculate the gradient or the SSE. So yeah, here I've taken the initial weight. It finds gradient, and then what the gradient tells you is you go into this direction. If you go into this direction, your you will get more closer to getting your minima. So this is your minimum cost here, or global minima. This is actually the one of the most simplest graphs, but there could be different graphs which have more than one, these valleys. These are called valleys here. So, but this is simple just for explanation. So yeah, so when you it gives you this direction, and after that you multiply this multiply your new weights with the learning rate, and then you again calculate the gradient, and then it again gives you this step. So as you might see here that when it the gradient, or when you first start the algorithm flow, it starts with bigger steps, but and as it tries to reach the global minima, it the steps are smaller then. So that's how it works. All right, so let's see what the different kinds of gradient descent are. So first is the batch gradient descent. Right, in this type of gradient descent, all the training data is taken into consideration. Okay, and then we then take the average of all the training examples and calculate the mean gradient based on the parameters. So this is great for convex or relatively small error manifolds. We move somewhat directly towards, okay, so this is basically, you have your training data, you take all the training data, and into consideration, you calculate gradients for all the examples, and at the end, you just average all of them, and then it gives you, the steps. So this is the first step, it's a big one, and then we go on to the minima. So there's actually a lot of advantages and disadvantages of this. As you might see that the whole all training data is taken into consideration in a single step, which means that a lot of computing resources are used. Okay, and it takes a lot of time. So it's basically good to use where you have a convex, or relatively smooth error manifolds. Okay, so that the algorithm goes on faster. But yeah, this is what batch means here. Batch means everything. They're taking the whole thing. All right, and next one is stochastic gradient descent. The as I said, the drawback of this batch descent is taken into consideration here. So, and we all know that, but we all know that the more the data, the better the insight you will get. Okay, so in stochastic descent method, what we have to do is we are doing is we are taking only the one example or one iteration this time, instead of the whole data set which we are taking in the batch gradient descent method. This means that it would go faster, but there would be more fluctuations, because if I take one iteration at one time, it would say that you go to positive direction, and then some other iteration tells me to go to negative direction. So my um, it would actually fluctuate a lot there. Okay, but in overall, if you see in a long run, the overall cost function will definitely decrease, and this method is definitely faster. Okay, and the third one is the mini batch gradient descent. Okay, so this method takes the best of both worlds. It takes the goodness of both previous methods, the batch method and the stochastic method. In batch method, as we see that more the data, the more better insights you get, and stochastic method gives you speed. So let's see, we take both of them and combine them together and make a better method, right? So in mini batch gradient descent method, what happens is we take a small batches, like small group of data, and you then run them instead of taking the whole data or taking just one iteration or just one part of data. You take one group of data. So that group actually, so it would actually give you more better insight, and it would be faster, right? So that's how it takes in that. This is how it looks like. It's better. All right, now I'll just show you. So this is first the normal gradient descent, or the batch method. It's the direct route to the minimum, but it takes more time, as I said earlier. And this is a stochastic descent method, and it takes fluctuating route to minima, but it takes less time due to only taking one example at a time. And this is the mini batch descent method. It's the best of both worlds, right? Yeah. So this is basically what is the gradient descent method is. This is the end of the tutorial one. Next time we'll dwell more into gradient boosting methods like XGBoost, ADA boost, stuff like that. Until then, have a good one.